So anyway, Internet of Materials, it's a concept, and it's also a project we held together with Vinnova in 2019, and it's also a concept that we are suggesting to start standardizing. So currently CIS is inviting to this, but more about that. I'm working at RISE, precisely as Malin, and I'm working in a group called Certification Development, a unit there, where our aim is to take mature knowledge into something that can be standardized, certified, verifiable, so we can really scale it up. And traceability is really one of those areas, of course. And that's where it came from. As you can see, I borrowed in some things we can think of. Circular economy, according to Ellen MacArthur. I myself now participating quite much, very heavy in Swedish expert in international standardization of circular economy. So this picture is of course not valid there, but everybody knows this one. Some things I work with, try to put QR codes straight into the foundry mold, and to be able to trace them, to give them birth already as a DNA already when they're born as individuals. RFID tags, we understand it's many ways to trace materials, but it's also reasons for it. We want to know that we're actually supporting good work conditions for our production of critical material and all other stuff like carbon dioxide traces and everything. So this is the kind of starting point. And why do we do this? One thing is to really find a different ways. Who would like to have traceability? We worked with, for example, SKF on their bearing houses. We know that they have experienced potentially very expensive and risky counterfeits. We all know brand names that looks nice and are expensive. Intel inside, we want to know what we buy from the outside, not having to go into it ourselves. And of course, materials that we trust, we want to know that they're based on trustful production systems and raw materials. Other things, as I already mentioned, ethical claims. Today, ethical claims is anything that is not really part of the product, but it's something that we should care about. Could be work, could be environment, could be carbon dioxide. Anything that our future promises, even about how do we take care of how do we promise recyclability, etc. All these ethical claims are important, and we really want to trace them. Logistics, everybody knows logistics works. Real logistics is trickier when we come to everything about recycling. To really find the way back, we need to find ways to standardize these real logistics of parts and components, materials, sorted waste. But much works, but not much else is still to do. So to say, to close the loop, everybody know that we're not exactly closing the loop, but we want to get back to the right point where anyone can take care of it in the best way to really make a circular economy. Innovation platforms, we really need more innovation platforms. This doesn't always look like innovation platform. This looks like a second-hand shop. Of course, a second-hand shop has to be an innovation platform where we can actually make these things into attractive goods rather than just second-hand. There should be high-quality furniture that can make many generations. How do you make that entire shift? Demolition materials. This doesn't look like a very nice way to demolish a house. Maybe it is, maybe it's the best way for precisely that house, but depending on what it is, all the material that is there has to be sorted out, and the more we can know about them, the more that is actually identifiable there, the better circular economy we can achieve. And then it's, of course, the entire sharing economy. We want to know that we actually have the tool we give our neighbor. We want to know that the tool we give is the one we get back, especially if it's not our neighbor, but it's someone else on the free market. We really want to keep track of our stuff that we share. Production and remanufacturing. Production is easy because we learned that for 200 years now. But when it comes to remanufacturing, in a very broad sense, we don't know very much about it. We can take it back to the factory that have all the skilled laborers and all the machinery. But when it comes to more general remanufacture on a global scale, we still are bad at that. We don't want to take back second-hand broken things on the highly costly logistics systems. So we might have to have share much more information about manufacturing stuff. And so this list here, which I will not go through, but these things we need to know when we want to be able to do that. Of course, material specifications, but maybe also something about business transactions. So we know that we don't lose track of materials that the claim it come from ethical mining, but someone shifted it, so now it's double the amount of ethical mining material on the market that and then one can take from there, etc. So quite a lot of different data. So I did not intend you to read this, but just to show that CAD drawings is good when you're going to remanufacture. Anyone can understand these things, but when looking at it, it's a lot of sharing, a lot of reasons for sharing, and it's a lot of different sectors, of course. And what we have done before, as I mentioned already, we worked with trying to make give birth to metals so that they already are individuals when they're born, and they can get we made individual LinkedIn sites and Facebook pages until they found us out. And anyway, we know that they can have individual lives, and we can tell them what they do and update data. It's not strange, but the thing we want to achieve is to get labels that cannot be removed, or not washed away, or not depending on the situation, it should be added to the correct material, in the correct way, so that it actually survives until the whatever future when it will be changed into something different. Also, we know that we need to trace them from primary material production, manufacturing, lots of different circular lifetimes. And over these circular lifetimes, we want these labels, identities to survive. Sometimes they cannot really just be added to, like a T-shirt. Where do you add it? Because after a while, one cut these labels away. So how to do this? There's a lot of innovation going on in all different types of material sectors. And what we want to see is something, could that be combined into general knowledge about labeling materials? We want to see that more specifically, not only labels that we stick on, and not only the design of QR codes as barcodes, which you think is excellent because we can use it in many situations, but not in all situations. So this is kind of the challenge we see. And what we also want to, of course, this is the thing, you see archipelago, lots of islands, because today everything is actually a lot of islands. And I think that this is the picture one should have as the challenge, that when we want to track things, all the tracks get lost, all the information get lost. The information systems are not compatible anymore, or the data as such is just kept somewhere because it might be secret, things like that. So during the time when we work with this, we also develop different kind of models to make people understand how we think of it. And here we see that we can have different local domains, which are islands, but we want to bridge them with maybe even secure islands. Of course, this is how it works in general. But just to show that the same way that we're working with today with digital product passports, we also think of this general approach of sharing data, that of course it should use the best cybersecurity solutions. And other approaches to it is, of course, when we have different parts that are branded, one put together components of for example cars, and you put them up and aggregate them. So lots of different general approaches to information systems design, but for the purpose of being able to trace material items and components and material items and full products all the way through the circular life cycles. We did this, as I said, in 2019 in a project, Vinnova project, together with Rise and SIS did it together, and we assessed then all then available standards that we could find that could enable this. The reason, of course, is that we shouldn't develop anything that is already there, and we just wanted to see what is there and what do we really need to develop. And I could actually take the next slide first here. So what we did, we mapped what do we know about how to describe organizations in general, of course, everything, because business works. So we really know how to address organizations and contracts. And what do we know about labeling of products and materials? We know quite much when it comes to these designed ones, even optical character recognition, like even my handwriting can be understood, RFID antennas and data matrix is these QR codes. Everything this is really well standardized. But it's not so well yet on understanding alloy contamination. How should we really work with that in a fast way to assess if we have specific DNA contaminations that is designed or such and such. So all the thick ones here are the ones that we couldn't really see that they're used yet to label stuff, to identify stuff, even if they are used practically here and there. And then coming to understand, this is the labeling, but then it's coming to using them, this kind of technologies for actually reading. One does it in different spots. There are some standards, some standards on how to start using like artificial intelligence, big data, and so to get better statistics for different identifiers. So this is good, it works. And the entire material, this product, CAD system, computer-aided manufacturing, product data management, everything there is excellent standards to just start using. So I could say that most of it exists, but when it comes to identifying material, it really is lacking. So in a way, one can see that the digital product passport is really based on what happens to be standardized, everything within our product domain. But when it comes over to the material domain, we are pretty insecure about how to handling them as materials. So suddenly they appear as products, then it's easy. And also when it handles that with logistics. So in general, we can see that there are standards, huge amounts of standards that can be used, but we cannot see that they're put together into one practical purpose. And what I said here, what we have done, the recent thing we've done now is that we start drawing this as we have the core. We need to identify materials, give them identities. We have all the existing computer manufacturing, design, etc. This kind of standards to describe things, but in different sectors, naming conventions are different. We have nomenclature issues to deal with, also sector standards that we have to handle them so that they can be translations between the sector independent and the sector specific. And they have to be set in the context of asset management, circular economy. Of course, we have to have information security on everything, etc. So what we have said then that is, if we base on what we have as existing sector standards, and independent sector standards, we apply sector standards to that. Then we can say that we describe a world on how to use standards for this kind of Internet of Materials, just a description, guidance. Then one can really base this digital product passport on such, and we get the circular economy solution. And that is in itself part of what we say resilient and sustainable business and society. And currently, precisely right now, 2 days ago, CIS invites to start looking at this and maybe start writing this workshop agreement, which we consider to be a test for the concept. Can we find different stakeholders who want to put this concept together on which is the smart way to use these different identifiers, which is the smart way to use resolvers, as we've seen that, for example, the X Foundation project that was released last week also used a resolver to shift between QR codes and different data sources. How should that be done in a more general, scalable way? I think that scalable is the wrong thing, because scalable is also that one, but more general, also coming down to mining materials and different types of data sources like CAD sources and everything. And so this is starting. We hope to get this work starting. We never know what the economic situation gives, what kind of freedom it gives to these kind of steps when that happens. And I just share now, Erik, you already mentioned what you have seen, but I really like this one that Daniel did. I think maybe Daniel is also in this room. How he has put together what he has seen is happening. This slope is some slope up to here. Actually, traceability works, and for the digital product passports and everything, all the needs we have. And he put together a number of projects that are happening all over the world. TraceMeta was part of that also, with tracing from mining to Scania and Volvo Trucks. Many of these ones I have not been in, but other colleagues and lots of other places where I have not participated. And we can see this product data, circularity data sheet that is also part of standardization now in circular economy. Trace for values, of course, here on the way, lifting everything up also. And Horizon is giving this digital euro program is also helping us, but we also need to have these laws and delegated acts that sets down the foot, like digital product passport again. And there's a pressure in value chains. There is standardization and so. And the standardization here, then that is kind of what we are working on. What I present now, we want to use the existing standards and we want to see them to be combined. And then I'm really happy to see that this Internet of Materials is understood in that way, that if we can achieve this agreement on how to use the existing standards, then we can have a very good way forward to make exchange smoother. And SIRPAS is of course up here. It's really on the edge here. So a roadmap. So that is my presentation on Internet of Materials. It's always a bit quick. It's always a bit drafty, but that's how it is.